Let's begin with transport layer. To understand transport layer, first of all you should get some motivation, right? You should know why we require transport layer. We will see that. Before that, let's begin with one safe point. We know that we have a network layer, correct? And what is the responsibility of network layer? Network layer is going to send your packets through some network, and it is going to ensure that they are somehow reaching your destination. But it is not compulsory that every packet which you are sending will reach destination. Sometimes you may lose your packets in this transit, correct? So that's why I can say that your network layer is unreliable. Sir, why we made unreliable network layer? Why can't we make a reliable network layer? When you make a reliable network layer, then we lose performance. For that, there will be definitely, we have to fix the route and everything, right? And we have to ask a simple question to router. My dear router, never discard any packet so that our network will be reliable. But we know that routers will discard our packets for flexibility. Otherwise, example, let's say this is a router, it will have some finite memory, and suddenly thousands of packets comes to this router, and if they overwhelm it, then definitely some of the packets will be discarded. That is unavoidable, right? Sir, why it is not avoidable? For that, you should have infinite memory. Otherwise, this router should not be suddenly attacked. Otherwise, suddenly should not be overwhelmed with a lot of packets. But in the network layer, you remember one thing, right? We use packet switching. Any packet can go to any path. Then suddenly what happens? Some of the routers will become busy and they will run out of the memory, right? So that's why I can't avoid that. When I can't avoid that, then definitely your network layer will become unreliable, right? And it is connectionless. That means we don't create connections so that your network layer can send the data as fast as it can, right? Now what we do is we try to build one more layer on top of this network layer, and we try to achieve the reliability functionality and whatever the functionality we need. Okay, if really we want, example, let's say you don't want reliability, some sort of, if you lose some of the packets, if doesn't matter for you, then definitely happily we can go for that model, so that this network layer will be definitely flexible and very comfortable, correct? So that is what we are going to do. So we are having transport layer only for giving a reliable communication between sender to receiver, and especially process to process. See, this is one important point. So transport layers very important feature is process to process communication. What is that, sir? I will tell you. Generally, network layer will have IP addresses, correct? So each IP address can recognize a device uniquely. Now see this situation. You have one device. That device has application layer. That application layer usually will have multiple process. That means there are multiple users, I can say, otherwise multiple programs who wants to use this network, right? Now we'll come to this network layer perspective. With respect to network layer perspective, so everyone is going to give messages, otherwise packets, to network layer, right? But forget about, let's say, this transport layer. Assume that we don't have transport layer. Now we have multiple processes, correct? Now every process gives their data to network layer, but network layer's idea, did you remember? It simply takes them, right, and it will keep that into datagram, right? It will form datagram and it will add IP address and it will send. The danger I will tell you. So this is like an house with two people, okay, Raju and Rani. So Raju and Rani wants to communicate with someone here, Rakesh and Suresh. See the story. Now your IP layer doesn't know who is giving the data. It knows only one thing. Someone will give that IP layer or network layer some data, and on IP address, that means house address, I will simply deliver the data if possible to that house. So example, Raju gives any data to this network layer, forget about transport layer, then the data will be taken by this network layer. Network layer asks only one question: my dear so-called application, where I have to send it? Then you will be providing the IP address. IP address will uniquely recognize the device to which we have to send the data. Because of that IP address, only data comes to this point. Okay, so finally it will reach the destination. But here network layer is going to take that data. Let's call it as D1. So that D1 has to be, I can say transferred to the original process. But here actually Raju and Rakesh are communicating. Finally, this data has to be given to Rakesh. But how network layer will know that network layer has only IP address? It's like, a postman who knows only house address, but doesn't know to whom he has to give. Then what is the danger you see? So Raju is writing a letter to Rakesh, but he did not mention it. He just wrote an address of the house. Then this network layer is going to transfer that to that house, but now anyone can read. And it will be, it's like a confusion, right? Suresh might read it, Rakesh might read it, and even this postman or network layer at here is having that confusion to whom we have to give. That's why I can say that we need one more layer which will bridge the gap. So which will do process to process communication. That's why, however, we know the reason for implementation of transport layer. Now you just believe that transport layer is required for reliability. Already we have seen. So though this process can directly give IP address followed by some extra thing which uniquely recognizes Raju. Right, Raju can say like this, my dear network layer, send the data to Rakesh and IP address I am going to give you followed by the person name also. Go and directly give to Rakesh, don't give to Suresh. In that way, so process can directly communicate with network layer. But here the another problem is reliability, which is very important. Your IP layer is or network layer is not reliable. That is what even worries me. That's why we are introducing transport layer. So now you have transport layer. Just believe it that we need transport layer. Then this transport layer has to coordinate this application layer and network layer. Network layer already we designed, right? So network layer is designed such a way that it is going to work with IP addresses. It's like house addresses. So whenever you give some house address, that network layer is going to simply send the data to that house address using IP addresses. Okay. Now house address is for house and for devices IP address. Okay. Now let's try to bridge, otherwise try to add some more layers to this network layer, that is transport layer. Now let's have transport layer which is a bridge between network layer and application layer. Now one thing you understood that we have to give something extra to network layer other than IP address. Okay, that's why so for process to process communication, simple IP addresses are not sufficient, we need more, right? So that's why we introduce port numbers. So we are going to use port numbers and every process is going to have a port number. We will see how port numbers can be generated, that's a separate issue. So assume that let's say every process has a port number. Let's give a port number 20 to this. P2 will have let's say port number 30. Then network layer is going to identify device and this process number is going to identify process number. From now onwards, device will be uniquely represented by IP address and process will be uniquely represented by port number. So 20 and IP is going to uniquely represent P1. Similarly here, let's say here it will have IP address, right? Here also process number, that means port number of P3, let's call 30 and IP address let's say 192 dot something 20 dot 40 dot 30. So that is going to right here 192 dot 20 dot 40 dot 30 and 30. This combination is going to uniquely represent this process. Okay. So finally, I want to say that transport layer's main feature or otherwise main service is it is going to give process to process communication. So second thing, for that definitely your transport layer is going to use a concept called port numbers. How port numbers will be generated? If you want to know, then you should understand who will generate the port numbers and what kind of port numbers we have. Everything we'll see. Finally, we have realized that we need unique identification number for every process, that you remember. Okay, now let's come to implementation part. That means we'll come to our internet. So majority of the time we do things for internet, correct? We understand theory related to internet, correct? Internet is having TCP/IP protocol suite. Okay, in that there is a transport layer. Okay, so that transport layer uses port numbers. For what? For uniquely identifying the process. So that is the relation between unique identification for process. Let's call it as process ID something and port numbers. Okay. In theory, we require a unique identification number, but in the implementations, especially in internet, we use port numbers to represent process ID. Okay. Now you know the reason for process ID. Ask yourself why. So that we can uniquely identify a process. That means one process can uniquely identify another process. But you remember one thing, process ID plus IP address, this combination is going to uniquely identify a particular application. Understand? So now we will see port numbers. That means in internet, how this problem will be solved? Port numbers. Sir, why don't we directly give some just random numbers to every process in our systems? Example, let's say I have a system. Okay, so in that we have applications. Let's call process. So there is a process, some process. At this moment we don't worry much about what is process, everything. That is application layer. At this moment we are in transport layer. So why don't you simply give a random number to every process uniquely, and this computer will have some IP address 192.192.20. Let's say 35. Then this IP address followed by this process ID 1 will become what? One unique identification number for a process, isn't it? What's the problem with this one? I will tell you. So far you did not understand how communication takes place, because we are going to communicate with remote devices, correct? Example, see this scenario. There is a sender A and receiver B or whatever. There are two systems which are connected like this. So here this is a network, a very big network you can assume. Now there is a process number 1. How process number 1 will communicate with process number 2 in B? How this process 1 will know that there is a process number 2? Second one, what is the identification number, everything, right? So that's why it will be a confusion, right? Example, let's say in the early morning, process 1 wants to say hello to process number 2. Then how this will be, working? Though you have transport layer, let's say imagine that you have a transport layer here, you have a transport layer here. So transport layer are going to communicate on behalf of you. Let's say you are an application. So process 1 is going to tell that, my dear transport layer, I say hello, you just send it. To whom? We will give IP address. Because of that hello message can come up to this transport layer. But after that, what about this, transport layer of this receiver to transport, that application layer or otherwise process? How this will go? Further, this P2's address P1 should know. That means P2's unique identification number, let's call 27, whatever it is. So that 27 should be known to P1, correct? So that's a problem. To avoid that, of course, with very difficult process we can do that. Finally P2 has to first of all inform that, Mr. P1, my number is 27 now. From now onwards you use 27 for communication, correct? Then you will be changing next time 30, then again you have to inform. So there should be lot of overhead. To avoid that, now you remember this thumb rule. So that's why this kind of different port numbers are introduced in TCP. That means whenever I say TCP, I am talking about internet. That means in internet how this problem is solved is, so these three kinds of numbers are generated by authority. That authority is ICANN. Okay, just remember the name, not so important for us especially. Now initially it was IANA. IANA used to generate IP addresses and port numbers, everything. It's an well-known authority. But now the authority is, otherwise nowadays ICANN is taking care of that. Okay, now forget about that and come to our topic. Well-known port numbers, registered port numbers and dynamic port numbers are the division. Sir, what is well-known port number? Some fixed. Remember one more thing. Actually, so you are going to get 16 bits to create a port number. Remember it. Okay. That means, so in internet, every process is going to have a 16-bit port number. Then how many possible sequences are possible with 16 bits? We know that it will be 2 power 0 to 2 power 15 minus 1. Okay. 2 power 0 is 1. 2 power it is 16 minus 1. 2 power 0 to 2 power 16 minus 1. So I think you can understand this. With 3 bits, how many numbers you can generate? Observe it first. 1 to 7. Okay, sorry, 0 to 7. In the same way, here also with 16 bits, how many numbers we can generate? All zeros, 0 to all ones, 2 to the power of 16 minus 1. In the same way, it would be 0 to 65,535. So these many unique identification numbers we can have in internet. Now, sir, well-known port number is what? Now, all these patterns finally are taken by ICANN. First of all, in that way you have to understand. Authority says that 16-bit pattern I will decide. So your ICANN is going to take every number 0 to 65,535. So what it did is 0 to 1023. It made well-known port numbers. That means these port numbers are fixed for some particular applications. So you will be realizing after some time, whenever I teach you application layer, there is a protocol called HTTP. Okay, so there is I can say, you can imagine this as an application, HTTP application, usually we use for web application. You have FTP for file transfer. So at this moment, don't worry about them much. So just remember the names FTP, SMTP in that way. So these are all popular process, I can say. So HTTP process always gets a port number 80. It is fixed for it. So that's why it is called well-known port number. Whenever anyone wants to communicate with HTTP process, then the port number to be used is 80 as a destination. Now similarly, FTP uses port number 20 or 21 in that way. SMTP 25. Okay. So in that way, these port numbers are fixed. They are called well-known port numbers. You can't use them. Sir, what does it mean? Why we use it? Simple. Now you have a process. Okay. Now I am talking about your device. So your device will have application layer, correct? So you will have applications. That means, so you will be having process. We will see the details very clearly when we learn application layer. At this moment, let's say you have some process. Process is nothing but a program, let's say for you. This process wants to communicate with someone. Then that process should have port number, right? So you can't take well-known port number because your process is not, popular. So popular process are HTTP process, okay, and FTP, SMTP. There are a lot of such processes. Authority will identify it. Okay, already authority identified them. They will get very popular numbers 0 to 1023. 1023 you can't take them. If you want to have, but every process, whether it is popular or ordinary, like your process, that process should take the numbers from dynamic port numbers. We will see that. So example, sir, why tell me one real world example where really this well-known port numbers are used. I will tell you. Example, let's say you want to access a mail, otherwise you want to access some server. Generally this entire world mostly uses this architecture, correct? Client server. So whenever you want to access some web page from some web server, okay, there is a web server, okay, and assume that there is a web server here, and let's say you are a client. This client wants to access some of the web pages from this web server. Example, Google or Amazon, anything. Now for that, two process should communicate. One is process number 1, second one process number 2. So here process number 1 is nothing but your process, client here. You are the client. You are going to open a process, and that means user. Now that user wants to access web pages. When a user wants to access a web page, so here HTTP process will be enabled. So here HTTP process will have port number 80. That means this process should use 80 for the communication. That means destination address is now 80 is the port number, and let's say the IP address is 192.20.20.35. So 192.20.20.35 and 80. Using this, we can access this web server. Okay. Sir, what is well-known port numbers then? I will tell you. So already you know that you have process to process communication. So, and we follow nowadays client server architecture. That means there will be a client process, there will be a server process. Example, let's say you have a web server, okay, and you want to access web pages through this server. Okay, let's say you are a user. Now generally what happens, there will be a web client here in your computer, that is nothing but one application. That application will fetch data from this web server. Okay, this is what happens. For that, finally this user's process should communicate with this web server. So web server is also a process. Now finally there is one client, there is one server. Now already I told you, if you want to really communicate with this web server, you should know the address of that. However, already I told you how to find out the IP address. We will see there is a protocol called domain name service. Using that we can find out the destination's IP address. But how to identify the port number? That's why well-known port numbers are introduced. That means out of these 0 to 65,535 patterns, some of the patterns are declared as well-known port numbers. They should be used only by this kind of famous process. In the world, there are some famous processes. One is, web server, okay, HTTP. We relate it to HTTP. We'll see the clear details in application layer. Similarly, for file transfers, example, you want to transfer a file from one server, then there should be one process, that is FTP process, okay. Now we will see that FTP will have again some well-known port number. In that way, all that important applications, example, you have a mail application, you want to access a mail. For that we have to communicate with mail server. So mail server is also one of the popular thing. That's why. So all these process, finally let me tell you one thing. There are some in the world, there are some important applications, okay, like HTTP. We will be seeing the details very clearly in application layer. Similarly, we will be having some file servers, we will be having some mail servers, okay. So we are going to access them. For that, you should know the port numbers before you start communication. That's why we have to give, let's imagine everything is a process. So every such process should have a famous number and it should be fixed number in that way. So that authority decided that, and authority is going to decide who is famous, who is not. Okay. So we can't declare ourselves as famous. So ICANN is going to going to fix which one is very important in the world. So HTTP is one thing. So HTTP server is going to get 80 port number and FTP is going to get something around 20 or 21. So mail server is going to get 25 in that way. So it is, I think, FTTP 21. So FTP, a mail server, HTTP in that way. Similarly, there are so many important, I can say, process. They are going to get well-known port numbers. From now onwards, any client wants to access web pages through some web server. That web servers, there will be a process called web server. That process always will be identified by port number 80. Remember it. Similarly, if anyone want to access some file in the remote location, then there should be a communication, there should be a process, okay. So file transfer process, let's say, that process port number is fixed always to 21 in that way. Example, you want to access a mail, for that there will be a client, there will be a server. Remember, in the world, all the communications generally follow this client server architecture. From now onwards, when there is a communication, majority of the times we can assume that there is a client, there is a server. So example, let's say you want to access a mail, then you will become a client and there will be a server, mail server, right? So Gmail maintains that mail servers. So that mail server will use a protocol called SMTP. So there will be a SMTP process at server. That process is going to do the communication with you. So that process is a well-known process that is going to have a port number 25. That's why now happily, without worrying about anything, we can access, we can download the pages, we can download the files, we can access our mails, because all such process, to do all these things, you are communicating with some processes, okay. That processes are well-known processes and they get well-known port numbers, okay. Some of the well-known processes are HTTP, FTP, SMTP. There are so many other things we will see in application layer, and their numbers are fixed, and the numbers generally given in the range of 0 to 1023. From now onwards, remember, well-known port numbers are 0 to 1023. We cannot touch them. We should not use them. Now, registered port numbers. Registered port numbers are from 1024 to 49,151, I think. Okay. So this registered port numbers are like this. They are not, I can say, popular. First of all, and you can use them, but you have to register them. So authority, we have to register these, I can say port numbers. Example, you want one registered port number. You want to register a port number. Go to authority and say, example, you want 1027. Okay. Then go and register. So from the now onwards, you can use it permanently. Okay. No others can use it. So whenever you declare that 1027 is your port number and it is already available, then from now onwards 1021, generally 1027 cannot be used by others. Okay. Now in that way there are registered port numbers, but remember you should register a port number which is already not registered. In that way, so this authority is going to maintain, avoid the duplicates. Example, already 1024 is registered by someone, you can't register. Okay, only unmarked, otherwise unregistered things you can register. It's not a problem because your authority is going to know, having the list of already registered and already not registered. Okay, not a problem. Now dynamic port numbers, these dynamic port numbers are important. Now sometimes actually we want to access some web pages. Majority of the 90% of the people are actually users, clients, right? Let's say as a student, generally what you do, you access a mail, you access some web pages, right? You Google it. Sometimes you refer various websites. That means you are a client, you are accessing the data, correct? You don't give the data to others most of the times, correct? So you are not center, you are just accessing the data from others. Similarly, you access some mails, correct? So all these things you are going to do, for that you are a client. When you are a client, then you are not famous, then well-known port number will not be given. So example, whenever you want to do the communication, first of all you want to access, let's say, web pages. For that, one process will be opened at your side. You are a client. Okay, let's say you are Raju. Imagine that you are this person and you opened a process. Why? Ask yourself, why this process? Because this process has to fetch some web pages. For that, this process has to be connected to some remote server, and that is HTTP server. Okay, so remaining details we'll see in application layer. Now this process has to communicate with this one, and we know the port number of this process. What is that? 80. Now here you are having one process, right? Client process. That process also should have port number, then only we can have communication. Already I told you, right? So that's why one number we have to pick, but we can't pick well-known port number, and we can't pick registered port number. That's why dynamic port numbers are given. They are in the range 49,152 to 65,535, in that way, last possible number, right? So let's fix something 50,000. This will be your port number temporarily. Okay, in the world at the same time others also can pick 50,000, not a problem. Okay, you will have your own IP address, correct? So that's why it will uniquely identify your process, not a problem. If in the other place like in Delhi there is another process which opens a port number 50,000, sir, duplicate, right? Yes, duplicate, but this Delhi's computer will have a different IP address. So definitely this process can be uniquely identified by anyone in the world, correct? In that way, not a problem. But in your computer, 50,000 should not be created two times. If there are two processes with same 50,000, confusion, right? So to avoid that, so in your computer generally this will be handled by OS. Okay, so OS is going to give you create this kind of process. So when OS create this kind of process, for everything it gives you different number. That's not a problem. We can plan our things such a way that every client or every process which we are going to open at our computer can have different process number. That means different port number, not a problem. But remember one thing, we have to take dynamic port numbers. The intention of dynamic port number is it's just temporary, it's a temporary thing. Just for communication we need a port number, that's why we are using it. Now that is the difference between well-known port numbers and dynamic port numbers. Registered port numbers are special, and especially you have some requirement. That means you want to have a process which is not very popular, but that process should have a particular fixed port number forever. For that you go and register some port number and advertise to world that this is my port number, in that way. Okay, but registered port numbers, we should check in the registered port number whether it is already registered or not a problem. Okay, now this is about all the port numbers. Now we will see remaining things about this transport layer. So far what happened is, you just realize that your transport layer is going to create a process to process communication. Okay, this is process, this is process. Now your entire transport layer story is how this process to process communication is successful. What are the things we have to take care in this one? Okay, now we will see. First thing, what are the things your transport layer is going to do is, it is going to take care of reliability. Okay, so why reliability is important? Sometimes you may require reliability, right? And we are going to take care of flow control, and we are going to take error control. These are all, I can say, services which are provided by your transport layer. Okay, error control, and we are going to do encapsulation. Okay, encapsulation and decapsulation, everything we'll see one by one. That's quite obvious. We know encapsulation, decapsulation, and we are going to provide, other than encapsulation, decapsulation, multiplexing and demultiplexing. We'll see one by one. Multiplexing, demultiplexing. So these are all very easy things to understand. Let's begin with reliability. Sometimes that application wants reliable data transfer. Then we have to take care of that reliability. Sir, why TCP layer? I will tell you. Recall all the layers now in your internet at least. Okay. In your internet there are 4 important layers. One is data link plus physical, that is one layer. I can say data link, roughly speaking, network layer, transport layer, application layer. Already we have seen sometimes like Ethernet is an example of data, which is implementing data link layer. That Ethernet was not reliable, right? Okay. So now there are some I can say technologies like Ethernet, they don't bother about reliability. Now after that, here you have network layer. One of the example of network layer, let's say in internet, the protocols we use is IP, right? That IP protocol is unreliable. So now data link layer protocols are sometimes unreliable, and IP network layer protocols are unreliable in internet. Then now we are at application. So between application and network we have transport layer. So at least this transport layer should be reliable. If you can't make this transport layer reliable, then so application layer is going to face lot of problems, because reliability cannot be guaranteed. That's why application layer forces this transport layer to achieve this reliability. Sometimes then your transport layer should be able to do that. That's why one of the service your transport layer can provide is reliability. Second one, flow control. What is flow control? Example, let's say there is a client and server. Okay, otherwise two process 1 and process 2. So process 1 is having lot of interest in communication. Otherwise process 1 is sending lot of data to process 2, but process 2 is not ready to take the data at this moment because it has a limited storage, right? Everyone will have different processing capacities. So process 2 at this moment is not ready to take the data. But this application doesn't know that. Okay, simply this process is sending. Someone should take care of balancing it. That's why that is the responsibility of transport layer. Application layer only focus on how to send the data. Now this transport layer is going to focus on how reliably we can send the data. That's why so this transport layer is going to do flow control. That means this transport layer will take care of this process 2's problems, like example, there is a buffer full at this process 2. Then this transport layer is going to communicate with this transport layer, and it is going to ensure that this kind of problem never arises. Okay, based on the second process capability. So sir, how we understand process 2? Simple. This transport layer at destination will understand process 2. We understand, we have a communication with the transport and transport. Through that we try to understand what is the limitation and capability of this other device. Based on that we send the data. Example, let's say process 1 wants to send 1000 packets, but this process 2 want to take only 500. So that process 2 is going to inform to this transport layer, my dear transport layer, our capacity only 500. I don't take more than that. Then this transport layer is going to communicate with this transport layer. It will say like this, our capacity is only 500. That is declared by my application layer. So you just tell that to process number 1. So here what this transport layer is going to do is, it is going to control this process 1 based on this figure. We will see how it will be done. Okay. So that is about flow control. Now error control. So whenever there are errors in the packet, we are going to ask this transport layer to retransmit. Okay, already we have seen error control mechanisms. So especially in TCP, that means up to now I am not teaching you particular protocols, correct? Internet uses what kind of protocols? There are two protocols, one is TCP, second one UDP. I will teach that. At this moment we are just seeing the theory, what kind of services we can offer at transport level. Okay, so these are all the various services generally any network and especially a transport layer in the network should offer. One is reliability, second one flow control, then error control. That means we have to take care of errors. When there is an error, what to do? We have to ask that sender to retransmit, right? All these things will be done at error control. Then encapsulation, decapsulation. What is encapsulation and decapsulation? Your process is going to give you one message, whatever it is. We have to create some header to it. That means we are going to implement lot of functionalities, right? So whatever the data which is given by your application, we are going to encapsulate it in our transport layer packet. So that is called encapsulation. Example, let's say this is TCP transport header. Okay, header. So using this header information, we are going to achieve all these functionalities and we send that to transport level. So here once it is received by transport layer, data comma header, this header will be removed and it will be the data will be given back. So finally what I want to say is here the application layer's data is taken and it is encapsulated into transport layer data, otherwise transport layer's packet, and after that at the receiver side the transport layer is decapsulating, I can say, otherwise removing the header, and it is giving data back. This process is called encapsulation and decapsulation. That is done by obviously transport layer. Not only transport layer, even data link layer, network layer, every layer will do encapsulation, decapsulation. So many times already we have seen it. Now multiplexing and demultiplexing. What is multiplexing and demultiplexing? We will see. This is not only story about internet's transport layer, it is the story about any network's transport layer generally. So you have multiple applications at application layer, otherwise process. Let's say you have three process A1, A2, A3 and you have one transport layer. So this transport layer is going to send the data to destination's transport layer, correct? So two things we should take care. One is how this application 1, application 2, application 3 are going to be isolated, otherwise abstracted from the communication. What we do is we take the data from A1, let's say D1, and A2 is giving data D2 and A3 is giving D3. Then somehow we send the data to here. Then this transport layer is going to receive D1 comma D2 comma D3. So this transport layer has to give D1 to the corresponding application. Let's say there is a application A1, application A2, application A3. Why I am taking A1, A2, A3? To show the correspondence. A1, A1 are communicating, A2, A2 are communicating, A3, A3 are communicating. Now this is one more responsibility of transport layer, to send the data exactly to the right application. D1 should go to A1, D2 should go to A2, D3 should go to A3. For that what to do? It's easy to understand. Sir, very simple sir. A1 is going to have a different identification number, correct? Port number. Example, A1's port number is something, for simplicity we take well-known port number, generally we should not take. Let's say 20 and 30 and 40. Okay. Now, so because we are talking about general network, general network, not internet. In internet we can't take 20, 30, 40 because they are well-known port numbers. So for general conversation, generally we are taking it. So A1's data will be given to A1, A2's data will be given to A2, A3's data will be given to D3 by transport layer. But how? For that what kind of things your transport layer will do? So that is called multiplexing and demultiplexing. Forget about that, how it will do, but that is the responsibility of your transport layer. That is what I want to tell you. Now let me revise what are the services your transport layer has to offer to application layer. One is this one, process to process communication. Second thing I can say, this flow control and error control, already we discussed, and encapsulation, decapsulation, yes. Then just we have seen multiplexing and demultiplexing. Apart from that, your transport layer is going to give two kinds of services. One is connection oriented service, second one connectionless service. Okay. So this is again one more important aspect of your transport layer. Still I am not using internet. Okay. So in internet we have some protocols, TCP protocol, UDP protocol. So that TCP and UDP protocols are going to implement these services, I can say. But just now at this moment I am just teaching you what kind of services your transport layer should offer. Okay. So process to process communication, generally flow control, error control, these are the very important services. Of course, some other services also can be offered, but whenever you see transport layer, so these services are generally are given. Okay. So encapsulation, decapsulation, multiplexing, demultiplexing, and connectionless service, connection oriented service. So what is connectionless and connection oriented? Already we have seen so many times, but let me revise it. In connectionless service, so your transport layer is going to take the data from your all the process, and it is going to deliver it to the appropriate process. How we will see. Now we'll see connectionless service. How this connectionless service will be offered. Okay. So in connectionless, you have, let's say, some process 1, process 2 at application level. This is your transport layer. Okay. And this is your network layer. So this process 1, process 2 will give data to transport layer. Transport layer is going to give this data to network layer. Whenever data comes to network layer, they will become datagrams. Okay. These datagrams will be transferred through this network. And we know the story how this will be transferred, right? So at the end, there will be destination. That destination is going to have network layer and transport layer and application layer, correct? So example, process 1 wants to communicate with process number 1, something, let's say A1. So how it will be done, we'll see. P1 will give data, let's say D1. What this transport layer will do is that transport layer will give this D1 to network layer. And this transport layer simply says that, my dear network layer, I will give you one IP address. Simply send this D1 to that IP address. Don't worry about remaining things. Then we know that whenever this network address is given for any message, then network layer is going to send that to exactly the right destination. Now because of the network layer, that will reach the right destination. Now this network layer is going to give it to transport layer. Assume that, let's say, there is only one transport layer entity. So the transport layer will take it and it will see that D1. D1 will have control information of transport layer and application layer. So here transport layer will see control information of that D1. By seeing that, it will understand that this is intended for application 1. Okay. Now here I will tell you the trick. Example, the port number is 30. Process number 1 says that, my dear transport layer, you prepare a packet. How you prepare it's up to you, but this data should go to port number 30. How you do doesn't matter. So transport layer creates this kind of packet, and that kind of packet will be given to network layer. My dear network layer, see, I am giving you some data. You simply ensure that that is reaching the destination. For that, see, 30 comma data 1, some remaining stuff, don't worry, only see my important things. So network layer asks what is the house address where it has to be delivered. So transport layer is going to provide IP address. But sir, how transport layer will know the IP address of this destination? Application is going to give it. We will be seeing one protocol called DNS protocol in internet. I am especially talking about internet. In internet you have DNS protocol. That DNS protocol generally can give IP address. That IP address will be taken by transport layer. Transport layer gives that to network layer. So that's why IP will be given. So given IP address, it will come to network layer. Now happily network layer understands that every information, and it will read all this header. After that it decapsulates. That means it will delete this header because it is only intended for network layer. Now exactly 30 comma D1 will be given to transport layer. Now see, I can say that this transport layer are communicating with same kind of details. See, 30 D1 is given to this transport layer. Now exactly 30 D1 is reached to transport layer. Now transport layer will see 30, 30 means A1, then immediately D1 will be given to A1 in that way. So P1 prepared a packet D1 and A1 is receiving the same packet D1, isn't it? So in that way I can say that two processes are communicating, two transport layers are communicating, and two network layers are communicating. Okay, that is one thing. Second thing, in connectionless, what we do is we simply send the data as everything as independent. That means all your data items are whatever you are sending here, they are all independent. Transport layer won't bother about loss of the data or anything. Example, there is a process P1 and P1 is sending some data items D1, D2, D3. Okay. So on behalf of process, your transport layer is going to send the data to destination, right? So forget about your network, everything. Definitely we have to send through network layer, but we see process to, here transport level communication. But how transport layer assumes the things we will see. This is transport layer here, transport layer here. So only we focus on process and transport layer. That means application level and transport level. First of all, D1 will be sent, after that D2, after that D3. So eventually D1, D2, D3 will receive at transport layer, correct? If really that network layer works correctly. Unfortunately, you know one thing, right? Whatever the datagrams you give to network layer, transport layer is giving to network layer. But network layer is going to send through network. So this network is unreliable. We have seen so many things like some of the routers discard packets. If that is the case, some of the two things can happen. One thing, your packets will come out of order, right? So one in possibility D1, D3, D2 in that way out of order. Second possibility, D1 comes, D3 comes, let's say D2 is missing. Sir, why D2 will miss? If you send D1, D2, D3, they have to come. No. But in the next level, if you see the next level, network layer is sending the packets through network. So in the network, anything can happen. So D2 can be lost. When D2 is lost, then who will take care of that? Network layer won't take care of that. Simply network layer try to send the data. So now application layer is busy with creating the logic part. Now we have only one thing, transport layer. That's why transport layer actually has to take care of that. But in connectionless service, whenever transport layer says that I offer connectionless service, even transport layer won't bother about it. Why, sir? There are some applications generally they don't bother about loss in the data. Example, let's say some 2% of the data is lost, or very generally. Do you think that 50% of the data will be lost? No. Through this network, maybe very rarely you lose the packets. You can say some 1%. There are some applications like video or audio applications. For that, some of the data if you lose doesn't matter. Still you can watch the video and you can listen to the audio, not a problem. That's why their delay, we can't tolerate the delay. That's why connectionless service will be implemented. Remember it. So there is an alternative for connectionless, that is connection oriented. To have connection orientedness, there is a overhead, that is a problem. We will be seeing that. Because of the overhead, people sometimes don't prefer this connection oriented service. Sometimes we prefer connectionless. Example, let's say sometimes you are sending small requests to some servers. If you lose that kind of packets, that will not be problem. Okay, so at this moment, let's say we don't focus on much on what kind of applications require connectionless service, what kind of applications require connection oriented. It's not the right thing now. Remember one thing, if some of the packets are lost in the transit, still your application doesn't have any problem, then such application will go with connectionless, because connection oriented service is difficult to maintain, because there is a lot of overhead. Initially we have to establish the connection, after that we have to tear down the connection, so there is a delay. If your application doesn't want the delay, then definitely we have to go for connectionless services. Okay, now finally what I want to tell you is transport layer offers connectionless service, connection oriented service. Now let me tell you how connection oriented service will work and what are the properties. Generally the important properties of your connection oriented service is, definitely packets will come in the order. Example, if you send 3 packets P1, P2, P3, I'm talking about transport level. Okay, so this is transport, here again transport. You can imagine it like a pipe. Of course, in the next level, internet is a network. So there are lot of routers, everything. So if you see this level, network level, definitely. So I'm not saying that your packets will go in a particular order. It is impossible because network is not in our hand, right? So in network we use packet switching. When you do packet switching, definitely out of order is possible. But if you see transport to transport, then this, in connection oriented service, definitely out of order can be eliminated. How we eliminate, we'll see. We send P1 through network, P2, P3, but your transport layer, whenever it offers connection oriented service, it will get out of order packets because it is taking the services of network layer. So network layer gives out of order sometimes like P2, P1, P3, but actually we sent P1, then P2, P3. So your transport layer is going to do ordering. So it will order the packets. That is a responsibility of transport layer. If your transport layer offers service called connection oriented service to application layer. Understand? Unfortunately, network layer is offering us connectionless service. Then transport layer to offer this connection oriented service, packets has to be reordered. That is the responsibility of your transport layer. Now I can say that transport layer reorders the packets, especially if it has to implement connection oriented service. So these are all various services your transport layer generally gives. Let's summarize. What are the services now? So far you have seen one service generally a typical transport layer offers is process to process communication. It ensures that, my dear process, because of me you can happily communicate with another process. Okay, don't worry about it, I will take care of that. Second thing, so we are going to have flow control. Yes, if you want to have flow control service, then that will be given. Error control will be given. Connection less service can be offered. Connection oriented service it will offer. Apart from that, multiplexing, demultiplexing it will do. That means, example, process 1 gives data and it wants to give it to application 1, then your transport layer uses multiplexing and demultiplexing process, and I mean that's simple technique, and it will give it to appropriate process. It can give that service also, it offers. Okay, so it depends on what kind of transport layer protocols you are using, but your general, I'm talking in generic sense, generally transport layer offers all these services. Okay, if you want, now either you want connectionless, you can. If you want connection oriented, you can get it. Apart from that, multiplexing, demultiplexing, encapsulation, decapsulation, anything else. One more service your transport layer is going to offer. Guess what it is? Stop the video and think about it. What kind of services you are expecting from transport layer? Think about it. Okay. So one more service which your transport layer offers is congestion control. Okay. So why congestion control is offered at this level, I will tell you. Because of course, network layer will take care of congestion control. Okay. But at the same time, who is creating the congestion? That means who is sending the data? Applications, right? So applications are busy creating the logic and everything. So we don't ask applications to take care of congestion control, and that's why network will do that. At the same time, transport layer. So what experienced people realize that this transport layer has to take congestion also, because transport layer is connected to application layer. We can stop the applications. We can say that, my dear application, wait for some time because there is a congestion in that way. So transport layer is going to stop each and every process to not to overwhelm with the data. Correct? So I can say like this. Of course, network layer can control the congestion, but before that, who is pumping the data into this one? Who is giving the data to network layer? Application. If you don't stop each and every application to not to send the data, then how this overall congestion process will be completed? Correct? So that's why we have to implement congestion at network layer. Second thing, we have to control the main source of this data, right? That is nothing but applications. That's why we stop the applications for some time. Further, transport layer is going to take care of the duty. So we are going to study congestion control techniques. How your transport layer is going to avoid the congestion. We will see that. Okay. Now this is about theory. So far we just learned theory part. How transport layer should look and what are the services it should offer. Now we will go to real applications. That means reality. So this entire thing is, I can say, theory. You can apply it to any network. Okay. Now we talk about internet. There are two things always, general network and our internet. This internet is famous. So this internet is having a protocol suite called TCP IP protocol suite. On that already we have studied IP network layer in this internet, and especially that network layer is implemented by protocol IP and SMTP we have seen, right? Sorry, not SMTP, ICMP. So we have seen all the protocols which supports your network layer in internet. Now this is the time to learn transport layer at internet. That is actually TCP and I mean there are three different protocols. One is TCP. Okay. Now I think by this time you should get the clarity. So far just we have studied theory related to any network, that means any computer networks. Okay. So we studied your transport layer in the generic sense. Now this is the time to go for our internet. In internet we have transport layer. That transport layer is implemented by three protocols. One is TCP, second one UDP. These are all very important. Third one is SCTP, and this is I think I can say this is new one, but these two are very popular, TCP, UDP. We will be studying TCP and UDP. We are just understanding what is the meaning of SCTP, how it works, but it's not important for us. In GATE exam we have only just TCP and UDP, I can say. Okay, now we'll study how this TCP protocol works, how this TCP protocol is going to implement all the features of transport layer. That is what your TCP has to do, right? And UDP is another alternative. Okay, your transport protocol, your transport layer functionality can be implemented by either TCP or UDP. It depends on the applications. Okay, we will see why these two and how these two differ and how to prefer TCP and when to prefer UDP, everything. Okay, let's begin with transport protocols. That's why we say this next topic, transport layer protocols. Okay, TCP, UDP, and whenever I say transport layer protocols, I am talking about in internet transport layer protocols. Okay.